Timeless concepts from Physics Helpline. In this video tutorial, we will discuss two multiple choice questions with only one correct option on thermal expansion and calorimetry taken from previous entrance examinations. The questions are as follows. Question 1. Two rods, one of aluminum and the other steel, having initial lengths L1 and L2 are connected together to form a single rod of length L1 plus L2. The coefficients of linear expansion of aluminum and steel respectively are alpha 1 and alpha 2. If the length of each rod increases by the same amount when their temperatures are increased by T degrees C, then the ratio L1 by L1 plus L2 is, the options are alpha 1 by alpha 2, alpha 2 by alpha 1, alpha 2 by alpha 1 plus alpha 2, and alpha 1 by alpha 1 plus alpha 2. Question 2. 2 kg of ice at minus 20 degrees C is mixed with 5 kg of water at 20 degrees C in an insulating vessel of negligible heat capacity. Calculate the final mass of water in the mixture. It is given that the specific heats of water and ice are 1 kilocalorie per kg per degree C and 0.5 kilocalorie per kg per degree C respectively, and the latent heat of fusion of ice is 80 kilocalories per kg. The options are 7 kg, 6 kg, 5.5 kg and 5 kg. First, let us solve the problem in question 1. It is about the thermal expansion of two rods of different material when heated through the same temperature range. When the temperature of a rod of length L and coefficient of linear expansion alpha is increased by T degrees C, the increase in its length is given by dL is equal to L alpha T. The two rods, one of aluminum and the other steel, are shown in the figure. For the aluminum rod, initial length is equal to L1, coefficient of linear expansion is equal to alpha 1, and change in temperature is equal to T degrees C. Therefore, the change in its length is given by dL1 is equal to L1 alpha 1 T. Similarly, for the steel rod, initial length is equal to L2, coefficient of linear expansion is equal to alpha 2, change in temperature is equal to T degrees C. Therefore, change in its length is given by dL2 is equal to L2 alpha 2 T. It is given in the question that dL1 is equal to dL2. This gives L1 by L2 is equal to alpha 2 by alpha 1, which implies L1 by L1 plus L2 is equal to alpha 2 by alpha 1 plus alpha 2. Therefore, the correct option is C, which is the answer to question 1. Now, we will solve the problem in question 2. It is about mixing of ice and water at different temperatures. We are required to find the final mass of water in the mixture. First, let us test whether all the ice will melt or not. We are given 2 kg of ice at minus 20 degrees C and 5 kg of water at 20 degrees C. All the ice will melt if the heat lost by 5 kg of water to cool from 20 degrees C to 0 degrees C is greater than the sum of the heat required to increase the temperature of 2 kg of ice from minus 20 degrees C to 0 degrees C and the heat required to melt 2 kg of ice. Now, the heat lost by 5 kg of water to cool from 20 degrees C to 0 degrees C is equal to ms theta which is equal to 100 kilocalories. Heat gained by 2 kg of ice to increase its temperature from minus 20 degrees C to 0 degrees C is equal to ms theta, which is equal to 20 kilocalories. And heat gained by 2 kg of ice to melt is equal to ml, which is equal to 160 kilocalories. Therefore, total heat gained is equal to 180 kilocalories and total heat lost is equal to 100 kilocalories. We observe that total heat gained is greater than the total heat lost. Therefore, we conclude that all the ice will not melt. Let the mass of ice that will melt is equal to mkg. Therefore, the heat lost by 5 kg of water to cool from 20 degrees C to 0 degrees C should be equal to heat gained by 2 kg of ice to increase its temperature from minus 20 degrees C to 0 degrees C plus the heat gained by mkg of ice to melt. We have already calculated the heat lost by 5 kg of water to cool from 20 degrees C to 0 degrees C, which is equal to 100 kilocalories. Therefore, we write Q1 is equal to 100 kilocalories. And the heat gained by 2 kg of ice from minus 20 degrees C to 0 degrees C, which is equal to 20 kilocalories. Therefore, we write Q2 is equal to 20 kilocalories. Now, heat gained by m kg of ice to melt is equal to 80 m kilocalories. Therefore, we write Q3 is equal to 80 m kilocalories. Now, equating total heat gained and total heat lost, we get 80 m plus 20 is equal to 100, which gives m is equal to 1 kg. Therefore, total mass of water in the mixture will be 5 kg plus 1 kg is equal to 6 kg. Therefore, the correct option is B, which is the answer to question 2. This completes the answers to the questions.